All right. Good afternoon, everyone. Hopefully you can hear
Bueno,
me.
atención.
All right. So good afternoon again. So hopefully you can hear me and see me. And thank you very much for joining this session. My name is Tamas, and I work as a senior developer experience engineer at a company called Cloudinary. And I'm here to talk to you about web performance fundamentals. And as part of this presentation, I'm going to essentially walk you through what I think web performance is and how it should be. And then if time permits, I will also do a very quick demo of a very interesting concept using one of the sort of newest web APIs that you have available at your disposals. Okay, so web performance one-on-one. So what is web performance? So in my sort of view, web performance is basically this collective term which encompasses a lot of things. Not just not just measuring something. It's not just how you implement something, but it's everything. It's basically the techniques that you adapt, how you implement them, how you measure the performance of your site, and very, very importantly, how do you provide a seamless experience for your end users. So this is what I would call web performance. It's not just one thing, but rather a collection of multiple things. And so clearly today we live in a world where the web is growing. And I did collect a few statistics, which I'm going to share with you, that came from the State of the Web report, which is a very good report from Google. And I have a link to that resource in one of my slides. So if you're not familiar with the report itself, then you can go out and check that out. But let's take a look at a few numbers. So if you take a look at 2010 and 11 collectively, the total amount of kilobytes of all the resources on a page averaged to be 657 kilobytes. So remember, this is on average of all the resources, all the fonts, the HTML, the CSS, the JavaScript, everything averaged to just 657 kilobytes. And these 650 kilobytes were a result on average of 68 separate requests and 37 requests on mobile. Now, clearly, this is half the requests on mobile because, 10 years ago, we didn't have that many smartphones that we have today. So naturally, this number would be a lot lower. But let's take a look at last year. So this is 2020. The average of all the resources that we requested on the sites went up from that relatively small number to about 2 megabytes, so 2042 kilobytes, which is a very, very big increase. And the result is where this number comes from is essentially 73 requests on desktop, which is not so much more than what we had 10 years ago, which is just 68 requests. But the big difference is there's 69 requests on mobile. So that's a whopping number, right? Compared to how many requests we've done 10 years ago. But this is, of course, how technology has shifted over over this time period. And so if we sort of dig a little bit deeper and we explore these numbers a little bit further by analyzing the various reports, we can see that in 2010 and 11, we did around 3 CSS requests, 2 font requests, 4 HTML requests, 11 JavaScript requests, averaging at around 133 kilobytes, so really, lightweight JavaScript stuff. 42 images, which is quite a large number. But then again, remember, maybe 10 years ago, if you've done some web design and web development, some of the things that we added to the web pages were controlled by images. So these are not necessarily actual images of products or cats and dogs and whatever, but rather also part of the UX design. And of course, there were no video requests. Now, comparing this to last year, we are requesting more CSS requests, we are requesting more CSS files, more fonts, less amount of HTML files, a lot more of JavaScript. So instead of just, on average 11 JavaScript files, we now request 21. And as opposed to those being around 100 kilobytes, it is now 450 kilobytes. So we are requesting a lot more JavaScript. the number of image requests have gone down. So we went from around 42 on average to just 26, but the size again tripled. So there's again a massive increase purely because today we live in the world of web, right, where everything is visual. Like you go to a website, it's going to be full of animations, images, and videos. And that being said, last year websites on average served around 2 videos as well. And of course, in terms of the sizes for those, video is one of the heaviest resources that you have on any website. So essentially, a lot has changed, right? How we develop websites has changed. We, have different frameworks, different deployment solutions, different tools and services at our disposals. How users consume the websites that we create has also changed because, the users are no longer using a desktop machine that is always plugged into the network, but rather they use mobile devices while they are sitting on a train, for example. And so how they consume our content has also changed in the past 10 years or so. And because of the combination of these two things, performance of websites matter, because if you don't have a website that is performing well, then you're going to lose potentially sales, you're going to lose profits, revenues, your users, registrations. Basically, a bad performing website is going to end up or resulting in a negative side effect one way or another in your business as well. Now, I really like this quote from Adi Osmani, who is a employee at Google. And last year he said that if you want a fast site, you must test on slow hardware regularly. And there are many, even though this is a very simple sentence and just a word, there are many important things in here. So in order for us to be able to create a fast site, we must test it on slow hardware, which also tells us that web performance is, it's not just a number. You can't associate a number with it, because what is fast for me could be slow for you, and what's fast for you could be slow for me. So it is highly going to be dependent on an individual. And then we also have to test on the slow hardware. And the reason why we have to test on a slow hardware is because we can't assume that everyone has access to the latest devices. And then you have to do this regularly. And why do you have to do this regularly? Because your infrastructure may change, some of your code may also change. So you have to make sure that every time you implement a change, you run your tests again in terms of how fast your website is. And of course, this needs to be an iterative cycle, because you need to not only do a test for web performance, you also need to somehow measure the results, so that when the next time you do your measurements, you can actually compare your results. So the question is, how do you measure if a particular site is slow or if it's fast? And there are quite a number of tools that you can use. And generally speaking, we can categorize them into these two sort of distinctive groups. There are field tools, and then there are lab tools as well. So field tools are, actually, let's start with lab tools, because that's more obvious. So lab tools are basically tools predominantly for developers. So these are the tools that you would use when you develop a website, right? So you use your Chrome DevTools or any other DevTools in modern browsers. You would also use a tool called Lighthouse, and that's part of the Chrome DevTools, for example. So it comes part of your DevTools. Then there's web page speed test, and there's also web speed test for images. Those are kind of the outliers, because you could run them on websites that are out there today, and not necessarily just sites that are available on your laptop. But still, those are probably tools for developers. Now, the main difference between what I call, or what I label, a lab tool and a field tool is that the lab tool is something that you do run on your machine. So it is going to take your network connection, your machine configuration, your sort of your architecture into consideration. Whereas the field tools, things like the Chrome User Experience Report, often referred to as just CRUX, or the Page Speed Insights Report, or the Search Console, which actually has this thing called the Core Web Vitals Report, which we're going to talk about as well, or something like a Web Vitals JavaScript library. Again, I'm going to come back to these, but these field tools basically measure how your users are accessing the site and how their performance looks like. So it's using their own system, what is being referred to as real user metric or RUM data. Essentially, you collect real user data from your users and then try to decide whether your site performs well or not, or whether your site is fast or not. Whereas with the lab tools, as I said, you just use your own environment, your own machine for trying to detect if your site is slow or fast. And so let's talk about these lab tools a little bit more in detail. So as I said before, they're really great for development purposes because they will identify some performance bottlenecks for you. They will identify some things that you may change in order for creating a site that works better. So for example, if we think about Lighthouse, you can just generate a Lighthouse report very easily today as part of your Chrome DevTools. It's going to give you a very thorough report where it's going to say things like, oh, you should reduce the total blocking JavaScript that you have, or you should use modern image formats as opposed to just using JPEGs everywhere. And it's going to give you these hints and suggestions. And if you go through those and fix them, your overall performance score is going to go up. And this is great. But remember, that is going to be specific to your device. In fact, if you basically give a site that you develop to someone else and you ask them to run it through their own Lighthouse tool, it's very likely that you're going to get different results, okay? Because they may have, a slower machine, a faster machine. They may use a faster network than you. So you have to be mindful that even though running a report on your machine does help while you're doing the development, that shouldn't be your sort of key metric. Like you can't say, well, I just created this site where I get 100 scores in all respective metrics in Lighthouse, so this is now a site that works amazingly well. That's not going to be the case, purely because you need to get the field data in as well. As part of Lighthouse, apart from Lighthouse, in Chrome DevTools, you also have access to the Performance tab, which again, if you're a developer, it can help you to, check particular things, especially around, rendering in JavaScript. It's going to highlight long processes for you. It's going to highlight Core Web Vitals metrics for you, which are, causing a negative impact on your web performance. And as I said, web page test and web speed test for images are two standalone tools that you can access. One I think is webpagetest.com, and the other one is, I'm forgetting the link, but it's in the resources section for install. You go there, you have a site deployed, you run it through one of these tools, you select the location where you want to run the test from, and it's going to provide you with a waterfall diagram and additional diagnostic information, which you can use to further enhance your performance. But again, that is not going to be representative of all your users, because even with web page tests, you're just going to say, run this test on a machine that is in, East Coast US, for example, or somewhere in Europe, or somewhere in, in Africa. And so again, it's going to give you a lot of information about what is wrong, and you can fix those, but it's still not going to give you this big picture. And so this is when we need to talk about the field tools. And these field tools, as I said, capture the real user metric. And this should be the primary indicator that says, whether your site is performing well or not to your user base. And it's going to take 28 days worth of data into consideration. It's going to measure, the performance metrics that you would get in Lighthouse as well from your visitors. And then using page speed insights, you can actually take a look at this data, and then you can now see the 10,000 users, the 100,000 users that have visited your site in the past 28 days, how was their experience? And if their experience was bad, then you know that you have a problem. You need to look into the details of that. But if the real user metric says, well, you're in the green, it's all 90 plus score that you get for all your visitors, then you can just lay back and enjoy your day. So as part of web performance, we also need to talk about the core web vitals. And the core web vitals are a set of metrics that were introduced by Google last year that have quite many impacts on your visitors as well as on yourself as a web developer. So these core web vital metrics, these three metrics that we can utilize, revolve around these three important aspects of web development. That's loading, interactivity, and then visual stability. Okay, each of these sort of themes would have a representative metric. And so for loading, we have largest contentful paint. For interactivity, we have the first input delay. And for visual stability, we have the cumulative layout shift. Now we're going to talk about these individually, but the reason why I'm going to just pause here is to tell you that as of, I think it was at some point this year, a couple of months ago, Google said that scoring well in these categories for these metrics is going to impact your search engine rankings. In other words, if you have a bad value for the largest contentful paint, or you have a very bad value for the cumulative layout shift, you may go down in your Google search page rankings. Okay, so this is how Google is kind of trying to allude towards the fact that web performance matters, and if you have a site that checks these metrics, you're just going to provide your users with a great experience, and Google is also rewarding you by allowing you to keep your search ranking results, or even getting higher up the ranks. What they also said is these metrics will be added to the the SEO metrics that they have, that use HTTPS. Your content is up to date. Your content is fresh. There are lots of metrics that they do collect in order to build up that search page ranking. And now these three metrics are also part of that calculation. And they also said that these are going to be important, especially for searches that are very generic. So for example, if I do search for just BMW, then naturally bmw.com or .co.uk is going to be in the first page, if not the first result. But if you search for something like a red sports car, which is a very generic search term, then it's going to be the freshness of the content, yada, 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 plus the three core web vitals metrics that will determine the final ranking. And so let's take a look at this. So first one is about loading, and the metric is called the largest contentful paint, or LCP, which basically says find the largest visible element on the page, and it can be an image, it can be a video with a poster attribute, it can be any of any text element, or any element that has a URL which then loads an image, and it's going to measure how long that particular element took to load. And then they say if it's somewhere between 0 and 2.5 seconds, then your LCP score is good. If it's 2.5 to 4, you need improvement. If it's 4 plus, it's providing your users a poor experience. So you need to look into that. Okay, so that's LCP. Then we have first input delay, which is basically a delta expressed in milliseconds, which is the delta between a user input and then the application processing that input. And it's not only the event listeners that matter here that you develop, but it's also the browser-based event listeners. So maybe you had this experience before where you loaded up a page, there was a search bar, and then you try to click into that search bar, or maybe try to tap into the search bar using your phone, but then your keyboard didn't come up. And then maybe after 5 seconds, you could type something into that search bar, right? So it's that delta that is being measured. And again, anything between 0 to 100 milliseconds is good. 100, 300 needs improvement. 300 plus, you're going to get a bad score. So that's first input delay. And then you have cumulative layout shift. Again, a very, very common thing that I experienced quite a lot myself, and I'm sure you have experienced this as well, whereby you load a page, maybe it's a news article, you start reading it, you start scrolling it, doesn't matter if it's on desktop or mobile, and then suddenly out of nowhere, an adword just, comes in the middle of your text. And now your text shifts. You had no idea what you were reading, what paragraph you're on, and now your whole layout has changed. So cumulative layout is basically measuring how much a page jumps around in terms of its content, right? So it's not in a millisecond. There's an actual formula behind this, but anything between 0 and 0.1, that's good. 0.1 to 0.25, it needs improvement. 0.25 plus, you're providing a better experience to your users, meaning that probably things are moving around on your page quite a lot, and they shouldn't, right? So this is for visual stability, and this the metric is called cumulative layout shift, or CLS. Okay, so I want to talk to you about a performance checklist as well. There's actually a very good article written by Vitaly Friedman for Smashing Magazine, who has this performance checklist for front-end developers, and he produces that article every year. So the 2021 version is out. It's really good. And this list kind of represents or summarizes what he said. So basically, when it comes to thinking about web performance, you have to pick the right environment. You have to think about how you optimize your assets. So these are your images. How do you minify your CSS and JavaScript files? Then your build optimization. So how do you enable the asset optimization as part of your build optimization? And then how do you do delivery optimization? Do you utilize, CDNs? Do you do lazy loading? So for every point that you see here, there would be at least 6, 7, or even 10 sub-bullet points that you need to take into consideration. There's also the backend. Do you use HTTPS? Which compression mechanism you use? Do you use Broadleaf? Do you use gzip? Do you use HTTP3, which is one of the latest initiatives on the web? But most importantly, and I have that sort of underlined, you need to be up to date. Okay, you need to be up to date with what you do, because the latest version of, say, Angular or React or Vue will also contain a lot of performance optimizations behind the scenes that you may not be aware of. So if you deliver the same project in Angular 2 and Angular 12, you will see significant differences in terms of performance. So just be up to date with all the tools and services that are around you, just so that you can see what is happening. Now, you can't, and this is very important, you just can't assume that people who are consuming your product and visiting your site have the latest MacBook Pros. You can't assume that they have the latest iPhone, and you can't assume that they have access to unlimited 5G connection, because that is not going to be the case. And therefore, I have this sort of term that I'm trying to coin here, which is called web equality. So try to think about everyone who is trying to access your website. Do not create stuff that is going to hinder the performance of your visitors. So try to provide the same experience to everyone, regardless of their network connections, regardless of their devices, regardless of their actual physical location, and never penalize the end user. Never get them to have a bad experience, never get them to download more stuff than what they are prepared to download. So these are just practices that you need to be aware of. And if you focus on these practices and you enable these practices, then of course you have already achieved web performance, because you take your users into consideration. Okay, so let me show you a demo before I need to wrap things up. So what I'll do, I'll show you this concept, which is using the Network Information API. So the Network Information API is not an API that a lot of developers are familiar with. And it's one of the newest APIs, but essentially what it allows you to do is to capture the connections, how fast a user's connection is. And the Network Information API can be accessed using the navigator.connection property, and in there's going to be a subproperty called effective type, which can have the following values: 4G, 3G, or 2G, or also slow-2G. And in this concept, what I'm doing is essentially I'm going to be showing a video, an MP4 file for users who are on a 4G connection. I'm going to show this file, which has some interesting flags in here, like an fauto flag. And even though it's an MP4 file, this is going to come up as a WebM file. And I'm going to show this for people on a 3G connection. And people on a 2G connection, that's a really, really slow connection, right? I'm just replacing the MP4 extension with the JPEG extension here. And because I am adding a flag called fauto into this Cloudinary URL, this is actually going to render a WebP image, which is going to be a really small image, and it's going to be really, really performant. So let's take a look at this in my browser. So let me just start this with npm start. And here we are. So we need to go to localhost 1234. And here is my demo project. So let me just zoom in a little bit. And what this does, it basically downloads, in this case, if I just move this up a little bit, it just downloads an MP4 file for me, okay? Which is fair enough. And I can play this, and I'm pretty sure you are a lot closer than to this place than I am. Lucky you. Anyway, so let's throttle the speed of this website. Let's go to fast 3G, and notice that I'm already printing that someone is in a 3G connection. I still have a video, and if I click on, I think it was this request here. If I click on the headers, let me just refresh. That's going to be easier. So if I select the video here, you will see that this should return a WebM file for me. So even though I'm still using the MP4 extension, because I'm using this service from Cloudinary, Cloudinary figures out the browser that I'm using, which is Chrome, and it will offer the most optimal video format for this browser, and that is WebM. So just by changing the type, I saved about 200 kilobytes in the size of the video. And again, this plays, right? So it's going to play. Now, what if I'm going to be on a slow 3G connection? In this case, as opposed to showing a video, I'm just showing an image, which is basically a frame from the same video file. Again, I'm using fauto via Cloudinary, which means that this is not serving a JPEG, but instead it's serving a WebP image that's only 17 kilobytes in size, okay? And again, what I did was just very, very simply take a frame out of that particular video file. Now, I could actually change this. So I can show you that if I just take this URL, this is the network request here. This is the network request now. And if I just add something like SO underscore maybe 10, it's going to take the frame at the 10th second of the video, which is going to be a different image, hopefully. Well, not really. Let's do maybe 14, but it's going to, you see how it kind of changes. It's always loading a different frame from my video, but the size is still 17 kilobytes, right? So with this approach, I can still provide a visual experience to my users regardless of what network connection that they have, right? Because if someone accesses my site on a 2G connection, I really, really don't want to start streaming a full HD video for them, but rather I'll show them a heavily optimized image, and they still get a sort of visual benefit of my website. So I could talk about this a lot more, but unfortunately, I think I'm running out of time. So let me show you the references here. So these are a couple of links out to various resources that I highly recommend that you read. Web performance is a very, very vast subject. So there's a lot of things that I could talk about and you could, discuss, from micro optimizations to how you build a, production JavaScript that, that gets to a bytecode level that is very optimal. but I tried to cover web performance at a very high level for you with a very interesting example, which I hoped that you enjoyed. So with that being said, gracias por tu atención, and let me see if you have any. I'm looking at my other screen, so let me see if you have any questions for me. And maybe if you don't have any questions now, let me just go back to my first slide. Just going to go back here and start this one. So under my name and signature, you see tpiros.dev. So that is my sort of website / portfolio, and there you have links to my LinkedIn, to my Twitter. So feel free to get in touch at a later point in time as well if you have any questions about anything related to web performance. Let me see the chat here. Thank you very much for sharing your knowledge. Great talk. Thank you. Thank you, Denada. Okay, wonderful. So, mi gente, muchísimas gracias. And where can you follow me? You can follow me on Twitter and on LinkedIn as well. You go to my site, and then you will find that the social logos, they're very visible on there. All right, so thank you again. I was actually thinking of doing this talk in Spanish, but then, I'm a bit timido, so I didn't do it. Maybe next time. Thank you very much again for your attention. This was fun, and I'll talk to you next time. Bye.